Today we learn about one of the most important properties in all of algebra, and that's the distributive property. The distributive property is very easy, but it's one that people forget to use in a lot of situations. So let's get to it. If I have 3 multiplied by a binomial, and this is the case where we use the distributive property, where I have a number on the outside written just like this. If it's written like this, this means multiplication. All right? Well, the distributive property is technically called the distributive property of multiplication. And I want you to write this down. Multiplication over addition or subtraction. It's the multiplication, it's the distributive property of multiplication, or we could say over top of addition or subtraction. So what happens with the distributive property is we distribute, that's the key word, we distribute multiplication over top of the addition or subtraction that's going on inside. So I distribute the multiplication of the 3 times the 2. So what is 3 times 2x? 6x. And notice I said it's over top of. So this minus is just going to come down for now. And then 3 times 7 is 21. And that is how the distributive property works. That'll be our first example. Let's do several more. Actually, we'll call this an example 2. That one was example 1. Let's say that I have 5 times n plus 3. Well, we distribute the multiplication over top to each of these terms. 5 times n is 5n plus 5 times 3, which is 15. Are those two like terms? Are 5n and 15 like terms? They are not like terms, so this right here is your answer. Sometimes you might have a binomial where there are no numbers on the inside, like this one. 12 times the binomial c minus d. It still works the same way. I'm going to distribute the multiplication to both of these. So my answer would be 12c minus 12d. Okay. And there's a lot of different ways this can look. Maybe they change the order. Maybe they write it this way. 3x plus 7, and then they write a 2 right there, like that. Now, if you remember me saying yesterday, multiplication has the commutative property as well. Let's come over here to the side for a minute. What's 7 times 5? 35. What's 5 times 7? Isn't it also 35? So if you change the order of multiplication, that's okay. 7 times 5 is the same thing as 5 times 7. So in this problem, isn't this the same thing as 2 times 3x plus 7? Yep. Exactly the same. So now we just do what we've been doing. Why don't you see if you can finish that problem without me? All right, your answer should have been 6x plus 14. All right. Now, sometimes you may have to use what we learned about exponents on a problem like this. 7y times 2y minus 4. We still use the distributive property the same way, but now we have to pay attention to exponents. Because when I multiply 7y times 2y, I get 14y to the second, because y times y is y squared, minus 7y times 4. That's a little bit easier. I can just do the 7 times the 4 and get 28y, because it's 7y times 4. Now, what we haven't talked about yet is if the number on the outside is a negative. We better do that, because you're going to see some like that tonight. What if I have negative 3 times 2y minus 7? Now, here's the good news. Everything's the same. You just have to remember your rules for multiplying with integers. All right? So, watch carefully. Negative 3 times positive 2 is what? Negative 6y will be my first term. Now, pay attention. Negative 3 times what kind of 7 is that? That's a negative 7. So a negative times a negative is a positive. So this becomes plus 21. Not plus a negative 21, just plus 21. All right? Do you see how that changed the signs? Let's do another one. What if I have negative 8 times y plus 5? Well, we're still going to use distributive property. Negative 8 times y is negative 8y. Negative 8 times positive 5 is negative 40. So how would I write it? Just minus 40. Now, you're also going to have some where you have to combine like terms at the end. A problem like this. That's a 3. Sometimes my Memeo pen acts crazy. 3 times 5x minus 4 minus 7 times 2x plus 10. A problem like this. This is kind of a two-part distributive property problem. It's all written in one sentence, but we kind of do it in two pieces. So watch carefully. Just take, even though it's written all in one, we work with each one separately. First, 3 times 5 is 15x. And then 3 times 4 is 12, so this will be minus 12. Now, when I get ready to do the second one, you have to pay attention. This is a very commonly missed problem. What kind of 7 is this? That's a negative 7. So when you distribute, you are distributing a negative 7. So, negative 7 times 2 is negative 14x. And negative 7 times positive 10 is negative 70. This problem is not done because now I can combine like terms. See, we're building on the concepts we've already learned. So I have 15x minus 14x. That's like 15 minus 14, which is what? 1x. So I'll have 1x, and then I have negative 12 combined with negative 70. That's negative 12 minus 70. So you start at negative 12, and the number line goes 70 to the left. That's negative 82. So I would write minus 82. X minus 8, or 1x minus 82 is my final answer. You will have several tonight where you have to do distributive property twice and combine like terms like that. One last problem. This problem is also very commonly missed. You will not see any like this on today's assignment, but you will see some like this on tomorrow's assignment. What do you think is the common mistake on this problem? Yes, people add the 7 and the 3 together first. That says 7 plus 3 times what's in parentheses. Order of operations says I multiply first. So what I have to do here is do distributive property first. Better write that off to the side in your notes. Let's just abbreviate distributive property first. So I do that, 3 times 2, it's going to be 6y minus 18. But I still have this 7 plus that. Can I combine like terms? What can I combine? I can combine these two terms. What is 7 minus 18? Isn't it negative 11? So my final answer is 6y minus 11. Or you could write it as negative 11 plus 6y. Either answer would work. And we're going to stop there for today.